Hello everybody, today we are going to talk about more types of variables in the C++ language. This is quite logical that there are more types. Right now we only know how to create variables that can store integer numbers. But we also need to know how to store real numbers, characters, sequence of characters. Before we start, let's remind about how to define variables, and let's talk about one problem that might happen when we use variables. If we want to define variable, we have to write what? Type of variable, and then name of variable, and then semicolon. We can also define in one line more than one variable. In order to do it, we should write something like that. Name of variable 1, name of variable 2, name of variable 3, and we could just continue that. Let's check it out if it's working. Int A, B, and C. Build and run. As you can see, our program is working well. We can also assign one of that variable in the same line. For example, I will assign that one, and I will assign that one. Okay. And let's build it. And it's working well. But let's see what values are stored in that variables right now. Cout A and line. And now let's just do that thing to the B and C. Okay, and now let's compile it. As you can see here, variable named A and C has got value that we assign, right? 40 and 20. But why variable B has that weird number here? If you compile that program on your computer, you might have even different number there. And why is it happening? It's because we haven't assigned any value to the variable named B. But this might be still a bit confusing. As I said in the previous lesson, every variable has got something like address. So let's send addresses of variables to the console output. So let's do something like that. Now let's do that way. Let's compile it. BNC, sorry. Okay. As you can see, the address is some weird numbers connected with some letters, right? Like the F, right? And the notation is called hexadecimal code. We don't need to understand it right now, but we should notice one thing. Each of that address is different, right? Here I have 44, 43, and C. So they differ from each other. And as I said in the previous lesson, when we define variable, so when we write something like int A, right? We are then allocating, reserving memory in the same time. It also means that we are allocating address for our variable, but allocating doesn't mean clearing the value that is under that address. Allocating means that we just want to reserve that space for other value. Okay? So if we write, for example, just int B, we are just allocating memory that already might have something assigned. But how is it possible? Still, how? Any programs that are running on our computer could use that space before for a special reason, for example, to store actual year. And when we stop using program that stored, for example, the actual year, the space in memory is again free. It can be then again allocated by other programs like the one that we have just written. but the value is still in there. The value under that address is not being removed. That's why under variable named b, we have some random value. So to avoid complications before using any variable, we should assign default values or just anything, right? And now we are sure what value is under the variable named b. Now we are sure that it will be 0, not some random number. Okay. And let's start from other integer type. Let's learn new variable types. Right now we can store in int, that one, numbers from about -2 billions to about +2 billions, right? But in the same time we have to allocate 4 bytes of memory. As you can probably guess, you don't need so large numbers in every situation. And if we don't need large numbers and we want to save memory, we can use, for example, something like that. Short integer, and let's name it T1. That type let us assign values that range from -32,768 to +32,767. And so now we can assign smaller values, but we need only 2 bytes of memory. So let's note that 2 bytes. And we don't need to write int when we define short integers. We can do it that way, like now, or we can just remove the int, and it's still the short integer. Let's assign some value to that guy, for example 5, and let's send it to the console output. As you can see, it's working fine. Here we have 5. Okay. Let's study something new now. What if I wanted to use real numbers, numbers at a fractional part? Now when I write something like, for example, that, and I compile it, as you can see, you are losing the value after the point, right? We lose that 6. We have only 5 on the console output. The type that can store real numbers are called in programming floating point numbers. There are 2 types, 2 of that types. Float, let's say something to that guy, and double. And let's set it to the console output. And let's compile it. As you can see, now we are not losing the part after the that. And now what's the difference between float and double? Float allocates 4 bytes of memory. Double allocates 8 bytes of memory. So it's just doubling the float, right? And to the float variable we can assign numbers that are up to 38 zeros, and here we can assign numbers that are up to 308 zeros. So it's a big difference, right? And in addition to this, double has got greater precision, which means that it can save more digits after the point. So it means that it can save more digits here, right? And because double variable can save more digits after the point, which means we should use doubles when we are calculating something important where the precision is needed, or we need to store very large numbers. Now let's talk about saving characters. Character, char, T4. Char is an abbreviation for character here. Okay. And let's send it to the console output. Let's assign something first. We can't do it that way because the compiler will try to assign here the variable named A. So that guy here. If we want to assign the character A, we should use something like apostrophes. Like that. Now, as you can see, everything is working fine. What if I wanted to store more than one character in the variable? If we want to store sequence of characters that are called strings, we should use string type. So, string, and let's do something like that, for example. And as you can see, text should be inside the quote signs for the sequence of characters. Let's send it to console output. And it's working well. Let's learn how to combine two different strings. So I have, for example, string x, assign value part 1, string y part 2, and now string combined strings equals x plus y. Cout combined strings and line. Let's see. As you can see, part 1 is now combined with part 2 in that variable that is called combined strings. We can add, for example, a space between them now, like that. So to combine two strings, we should just use the plus signs. Right? It's working well. Let's talk about Boolean type now. Boolean. True or false? Well, bool is a type that can store only two values, true or false. Maybe let's send it to the console output and compile it. As you can see, we don't have here something like true. We have 1 here, right? But here is true. Why? Every number that is not 0 is going to be true in the C++ language. 0 is representing false. So false is always 0. Every other number is true. Let's check it out. For example, I will write false. As you can see, we have 0 here. And let's now write something like that. As you can see, we have 1 here. 1 is representing true. 1 is representing true. And let's assign the negative number. As you can see, it's 1. And now 0. And it's 0. Okay, so everything is working well, like I said. Now let's talk about unsigned types of variables. When we look at that guy here, I told you that it can have values from minus 32,768 to 32,767. But there are many situations where we don't need negative numbers. Then we can remove the minus signs, remove it, right? And we are making them unsigned types because it's without that sign. By removing negative part of integer, we are increasing amount of positive numbers by amount of negative numbers. So for unsigned short int, we could assign a value that range from, let's do it, for unsigned short int 0 to 65,535, and that number here is a sum of that numbers here. You can check it out. And let's send it to the console output. Let's create first that way. Cout. As you can see, it's working well. Let's talk about that we can also remove that integer here. Unsigned short is unsigned short integer. Alright, it's working well. We can add unsigned to all other types, right? Float, double, so it's working the same. And let's talk about constant variables now. There might be situations where we're gonna use something in our program many times, and we also want to make it unchangeable by mistake. In order to do it, we have to add before type of a variable a word const, which is abbreviation for constant. So for example, we have string, I will name it name of game, Conqueror of C++, for example, and I don't want this name being changed, so I will add const here. And now let's send it to console output. As you can see, it's working well. And as you have noticed, I'm using uppercase for the name of constant variable. You don't have to do it that way, but it's a good idea, because when your programs gets longer, you will know what is constant variable just by looking at the name of variable, right? It's uppercase, so it's the constant for sure. And we'll know that we can't change the value of this variable from the other part of program. Let's read out, so we'll see if I'm lying or not. Okay, name of game, and now something. Let's build it. And as you can see, we have error here. We can do it. So I didn't lie. Okay, that's all in this lesson. Thank you very much.